So the final way to solve a system of equations is through the use of a matrix. But before we can do that, we're going to have to look at how you actually set up a matrix and what all the elements in a matrix are. So you can see here we've got a matrix set up with A equals, and then you have brackets surrounding 2 rows of numbers and 3 columns of numbers. So the top row, 1, 2, 3, we would call that row 1. The bottom row, 2, 2, 3, we would call that row 2. We would then call the first column 1, 2, the second column is 2, 2, and the third column is 3, 3. Each of the individual numbers written within the matrix is called an element. So if we want to identify a single element, we're going to choose the row followed by the column, and we're going to write that as a number. So if we've got A21, what that means is row 2 and column 1. So A21 would be equal to 2. In this first question, we're going to identify a matrix element. So we're given what is element A23 in matrix A. So the 23 indicates to us first the row followed by the column. So identify row 2, that's 0, 5, 8, and 6. Then identify column 3, which is 17, 8, and 10. Where do the column and the row intersect at? They intersect at 8. So A23 is equal to 8. Now the next thing we're going to look at with matrices is how to write equations as a matrix. So when we do this, you're going to have your standard bracket set up, but you notice that there's going to be a vertical line separating the last elements or the last column of elements from all the other columns. That vertical line basically acts as your equal sign. You're going to write your equations across the matrix. So whatever your coefficient for x is, that's going to go top left corner in element 11. Then y is going to be element 12, and then the solution to that would be element 13. Your second equation would go in the second row. So element 21 is the coefficient of x, element 22 is the coefficient for y, and then element 23 is the solution for that second equation. And you can make as many of these as you need with as many places for variables and with as many places as you need for equations. If any variables do not have a coefficient, remember that you're going to assume that it's a 1. And if any variables are missing, so if you're given an equation like x equals 8, so there's no y, you have to insert a 0 into the place where y would be. So in problem number 2a, we're actually going to go ahead and place these two equations into a matrix. We're given 2x plus y equals 9 and x minus 6y equals negative 1. So in our first equation, we have coefficients of 2 and 1 and a constant of 9. So when we draw our brackets in, remember to put the vertical line in where the equal sign would go. Since we have a 2 and a 1, that's going to go in the first row and first column and first row and second column. So 2, 1. The solution to that equation is going to go in the third column, so we'll place 9 there. In our second equation, we have a coefficient of 1, we have another coefficient of negative 6, and then we have a constant of negative 1. So place those in order in the second row, and there's your solution, or there is your representation of those two equations in a matrix. In 2b, we're going to do the same thing as what we did in 2a, except now we've got 3 equations. We're given x minus 3y plus z equals 6, x plus 3z equals 12, and y equals negative 5x plus 1. So go ahead and take that third equation and move the negative 5x over to the other side to get 5x plus y equals 1. Now draw the brackets, draw the vertical line, and we're going to look at that first equation, which has coefficients of 1, negative 3, and 1, and then a solution of 6. So go ahead and write that across the top as your first row. Then we have x has a coefficient of 1, and z has a coefficient of 3, so that means that y has a coefficient of 0. So we go 1, 0, and 3 with a constant of 12. The last equation, we've got a 5x, and we've got a 1y, and we've got a 0z. So go 5, 1, 0, and then the constant is 1, so place that in the last element spot. In problem number 3, we're going to write a system from a matrix. So the question is, what linear system of equations does the matrix represent? We're given a matrix of 5, 2, and 7, and 0, 1, and 9. Again, remember that the vertical line is the equal sign, and the 5 and the 2 represent an x value and a y value. So we're going to go 5x plus 2y equals 7. Then in the second row, we've got a 0, 1, and 9. So we have a 0x, which means we don't have to write it. And then we have a 1y equals 9, so y equals 9. All right, boys and girls, this is where it gets fun. We're going to solve a system using a matrix. So we're given x plus 4y equals -1 and 2x plus 5y equals 4. So your first step is to go ahead and put that into a matrix. So we have brackets with 1, 4, and -1, 2, 5, and 4. Our goal here is to have a top line where the first two elements are 1 and 0. Then the bottom line, we're looking to have a 0 and 1. What this would mean would be the top line would be your x value and the bottom line would be your y value. So to do this, we're going to do something similar to elimination. So once you've got it put into your bracket, go ahead and rewrite it as a matrix without the brackets. So basically as your coefficients and your constant. And you can see we've got 1, 4, and -1, and 2, 5, and 4. We're going to multiply the top line by -2. When we multiply the top line by -2, we get -2, -8, and 2. This means that the 2 and the -2 are going to eliminate each other. The 5 and the -8 are going to give you -3, and the 4 and the 2 are going to give you 6. You're going to rewrite your bracket or rewrite your matrix with that new set of numbers in the bottom part of the matrix. Because look at what the value of x is. The value of x is 0, and that means that we're going to be looking to make the value of y, which is currently -3, into a 1. So once you've got your bracket rewritten, or your matrix rewritten, go ahead and take that bottom line, rewrite it outside, and what we're going to do in order to make that y value into 1 is we need to multiply everything by -1/3. So when we multiply everything in that line by -1/3, we get 0, 1, and -2. We now know that the value of y is going to be -2 because we have a 0 and a 1 in the bottom part of our matrix. Then we've still got the 1, 4, and the -1 to deal with. Now we're completely fine with that 1 where the x is. So what we need to do is we need to try and get rid of the 4. So we're going to, again, write both of our equations, or what represents our equations, without the brackets. So we've got 1, 4, -1, and 0, 1, and -2. We're going to multiply the bottom row by -4. When we do that, our bottom row becomes 0, -4, and 8. So 1 plus 0 is 1, 4 minus 4 is 0, and -1 plus 8 is going to give us 7. So now we have a 0 in place of y, and we have a 1 in place of the x, which means that we can now plug that back into our top row in the matrix, and we get 1, 0, 7, and we get 0, 1, -2. This means that the solution to our system is the ordered pair 7, -2.